So we're going to talk about rain right now, and this is just a pretty simple diagram to explain rain period that I will be referencing during this maybe last video. I'm not sure. Not definitely not last video ever, but talking about climate, maybe things that influence climate. So I want you to remember the major influence of altitude. As you go up, things get cooler, and I want you to remember that warm air rises a lot better than cool air. Think of a hot air balloon. And I want you to remember that cool air holds moisture worse than warm air. So as warm, moist air is rising, once it hits a certain level, it cools and condenses, and that cool air can't hang on to that moisture as long, so guess what? It starts to rain. Okay, and that's pretty much consistent for everything that we're going to be talking about. What I want you to there you are. What I want you to understand is that the types of rain, how does this happen? What is influencing the rise of moisture? And for the most part, it's going to be a couple different reasons. So I've got three types of rainfall. Okay, we're going to do relief rain, convectional rain, and frontal. Don't worry about the cyclonic. It makes sense when we talk about fronts, which I've asked you to learn in these three things. I have asked you to take a look at and find examples of how these happen. Okay, so convectional, kind of like volcanoes, remember magma, we need that convection. So whenever there's heat relief, there has to be some sort of landscape, some topography that forces things up. And fronts, what do you think would happen when a cold air front or air mass meets a warm one? Which one would be forced up? Warm up, cool down. Okay, think of your upstairs or if your basements, those of you that have them. Where's the coolest place to hang out in the summer? Downstairs. It's cooler. Where is it super warm? Upstairs. What's the purpose behind a hot air balloon? You put hot air in a balloon and it goes up. Okay, that makes a big difference for a lot of these. All right, so rain period, I just showed you that. I'll skip over it. Basically, you need moisture. You need something to push that moisture up. You need altitude, which cools that moisture. That's where you get condensation and then precipitation based on that. So relief rainfall, basically air is forced up via topography, a mountain. Perfect example would be Vancouver. Okay? You have mountains right on the coast. You get that warm ocean breeze coming. It's like a ski jump. It just forces you up into altitude. Warm air cools, condenses. What do you know? They get a lot of rain. Okay? Some other terms I asked you to know: windward versus leeward side. So I'm going to explain that through some diagrams here as well. It's pretty simple. Vancouver would be on the windward side where the wind hits and generally where most of the rain falls. If you go up, the air continues to go, but now it's lost its moisture. On the other side of that mountain range, you get places like Kelowna and Kamloops, which are almost desert-like. Definitely very different. They have relief, but they've lost all that moisture content on the Vancouver, the windward side. So they would be the rain shadow, and the leeward side on the other side of the mountain. Much drier than the windward side. Okay? Just took care of that. So here's a very brutal drawing. I wish I could do myself, but then that would involve me carrying this and that back and forth. But basically, as you can see, ocean, wind blowing, it forced up, cools and condenses, rain falls here on the windward side, but the wind continues, goes down, and you have the leeward side. Okay, and that's evident everywhere. The driest place on the planet, the Atacama Desert, is right on the other side of the Andes in South America, in Chile. No rainfall because the very cool current that hits the ocean drops all the rain right on the ocean side, the windward side, but it continues. Atacama Desert hasn't had rain for years at some points, okay? So here's some climate graphs, your first kind of glimpse at climate graphs. I don't know how well you can see it, especially the blue, but the blue represents precipitation, okay? The red represents temperatures. So these are in 4 different places on Vancouver Island, and at the top here, the 4 different places are on the map. You can see basically, so hang on a second. You can see basically Port Hardy is here, that's Port Hardy. Tofino would be down here, Nanaimo is up here, and Victoria is around here. So based on windward, leeward, which ones would you basically, like if you were just to see this map here, I would say based on the knowledge you have already, you would be able to kind of give an estimate of which place would probably receive more rain, okay? And I bet you nailed it. Tofino, the one that is on the coast. And if you don't know anything about Vancouver Island, it's kind of really mountainous all the way up the middle, okay? So Victoria and Nanaimo and Port Hardy are a little bit more sheltered and on that leeward side. Obviously Port Hardy, there's less sheltering, so they would get, this is all mountains here too, protecting Victoria. So Victoria doesn't really get as much rainfall as Vancouver does, even though it's kind of, it is on the coast, right? So Tofino by far wins the race in terms of most rainfall, precipitation based on the relief rainfall, windward versus leeward kind of thing. Yeah, very lush. If you've ever been to Vancouver Island, you know what I'm talking about. It's very lush and almost kind of rainforesty. Actually, Canada's only rainforest is found right where Tofino is. Okay? If you ever have a chance, you got to go there. It's beautiful. Versus a place like Kamloops, as I talked about, it's kind of, you don't see the trees. You generally find trees where there's moisture. Okay, and this is kind of, it's a beautiful golf course, but it's even in the back there, you don't really see the forests as much. So even this map here, that's Vancouver Island. The coast is greener than the interior where it's generally dry. This is usually the place where you have the worst forest fires because there's no precipitation and in some cases there's a lot of trees. Convectional rain, okay, you need heat. Okay, you need heat. So if you've been to the tropics, you know what I'm talking about in rain. We don't get rainstorms like they get rainstorms. If you're surrounded by water, you get a tremendous amount of evaporation, and that's the thing that drives that moisture up, cools and condenses, falls as rainfall, okay? That's basically the rule behind this. We need heat to act like an air balloon, push that moisture up, and it's being pushed a lot because you have nothing but moisture around the ocean and a lot of evaporation because it's hot constantly. And even in Winnipeg, this is what we experience in thunderstorms. You can even see it as the clouds start to bulge and billow and they turn dark and scary. And what do you know, around 5, 6 o'clock at night, we have a thunderstorm. Okay? Sun heats, evaporation, rain period. Okay? That's kind of the way it works. Yeah, that just, yeah. Okay? So this is another brutal drawing of basically what I have on the board here, but you need this heat to drive that evaporation, cools and condenses, can't hang on to the moisture as well. What do you know? We get rain. Okay? Frontal, the last, don't worry about cyclonic. It's easier when you think of frontal because we're talking about 2 air masses, air fronts, okay, and what happens when they meet. Okay? When warm, moist air meets cool, drier air, one will stay down and one will go up. Okay, cool air is denser. Okay, warm air goes up. So there's always going to be that winner. And when warm air is forced up, okay, yeah, that's what happens. Yep, there it is, fall, springtime. So this is what we experience whenever there's not a tremendous amount of heat. So everything that we've had in this last couple of weeks here, the snow, the warm weather, the rain, that's this. Okay, any snowfall in the wintertime Again, we rely on warm air to bring any moisture in, and it only snows when it's a little bit warmer. It's never going to snow at -30 or 25 or whatever. There's not enough moisture in the air, okay? So basically, this is a hard one to see here, but I'll put a line here, okay? This is the front, okay? So if you have a warm front and a cool front, warm air is pushed up, carries more moisture, okay? Cools and condenses. That's what happens, okay? So, moving on, I'm going to talk about climate graphs. Actually, I like that stick. I'm going to hang on to the stick, okay? I'm going to talk about climate graphs. So I asked you to look this up. Climate graphs, it's a very simple definition. It will give you an information on the temperature and precipitation of a given region for the year, okay? So you can see when it's hot and when it's cold, or does anything change temperature-wise? You can see when it's rainier or when it's drier. So it gives you a nice snapshot of a place's climate on a given year, okay? So these are based on averages. Of course, there's going to be different years, but these would be the usual kinds of things. Remember, climate is what we expect. Weather is what we get. So be conscious that, yes, I'll show you Winnipeg's climate graph. It may have been different this year, but based on averages of lots of years, this would be the usual, okay? So temperature will usually be with a line, and precipitation will usually be bar graphs, okay? So that's going to be consistent. So here in the so remember when we talk about maritime versus continental. Maritimes have smaller temperature ranges. Continental places have larger temperature ranges. Maritime places have more rain. Continental places have less rain. Do you remember when they get rainy? Maritime places would get rainier or more precipitation in their cooler months. Continental places would get more precipitation in their warmer months. That's a general rule, okay? So I know it's really hard to see these things. You can't find any climate graphs that are dark, so you're going to have to bear with me and trust me that I'm telling the truth about these things, but you will have the notes to look at them as I explain them if need be. So if I took that name off there, and I would like you to understand, based on looking at a climate graph, I would like you to be able to figure out where approximately in the world you are, based on what the temperature line is doing. Is it flat? Where are you? Because if it's flat and hot, I would guess the equator. If it goes from very cold to very warm, I would guess a place like where you and I live, right? But if I took maritime off there and you just saw this, do you have any guesses? Which again, you can't see. The precipitation is consistent all year. The temperature line goes from 6 to 18. That's a temperature range of 12. So right off the bat, I would guess this place is a maritime place. There's lots of rain all year, and the temperature range is low. Okay, another thing I can figure out, is this in the northern or southern hemisphere? Because remember, based on something else we should know, temperatures fluctuate, seasons are the exact opposite. So June and July will be the coldest months down south in the southern hemisphere. We know when we experience our warmest months, right? So this is a place called Scotland, okay? This place, continental. So again, if I took continental off there, and I know you can't see it as well as I can, but the temperature range goes from -15 to +20. That's a 35-degree temperature range. Getting up there, okay? And there's much bigger blue bars in April, May, June, July, and August. Closer to the winter time. So this is from January to December, and temperatures go like this. Precipitation goes like that. When does continental places get more rain? When it's warm. Okay? You ever heard of this place? Maybe. Okay, I'm going to end it there so that we can talk about these more specifically. Stay tuned.